Hello, everyone. It's cold and cloudy out there now. Too cold to venture out under the stars for yourself. So that means it's time for another season of online viewing sessions featuring the Kalamazoo Astronomical Society Remote Telescope. So welcome, everyone, again, and I apologize for the slight delay. Maybe I'll show you the satellite view here soon. It's kind of hilarious. Over the entire state of Arizona, it's completely clear, except for one little cloud right over Arizona Sky Village that's kind of taken up the entire all sky camera. I kid you not, but now it's finally dissipated and or moved out. So I was finally able to get the telescopes focused, and we are ready to go. So it is great to have you all here. And when you do get a chance, if you're joining us for the first time or even the second time or third time or more, you know, let us know where you're from in the chat. It's great to have people, of course, from Southwest Michigan. And we do tend to have people attend from not just around the country, but around the world. And so we welcome everyone here to another season of online viewing sessions. All right, so one thing about the very first session is I really should just start all of these at 9 o'clock because it is not completely dark out there yet, not dark enough to image yet. But since this is the first session of the year, I always like to give a little bit of intro to the remote telescope and Arizona Sky Village. So let me go ahead and share my screen here again, and you'll see the PowerPoint file. So you should see, of course, the title slide there again. Kevin will tell me if we don't, my lovely co-host. And so you can see the image here is a panorama of Arizona Sky Village. And turning on my laser pointer here, this area here, which looks pretty cool, that's Cave Creek Canyon. And of course, this panorama is from Rick Benno, and that's his observatory right here. He has a 24-inch plane wave in there. I know it looks pretty tiny, but yeah, there's a pretty big telescope in there. And our observatory that our telescope is in is right here. So this is Peishi Observatory, and this is the home of Mike Patton, who's one of the members of the Kalamazoo Astronomical Society. And years ago, I won't give you the detailed timeline breakdown, but he offered us space in his observatory. And so we launched a long fundraising campaign. And of course, long story short, it was very successful. And now we've had the remote telescope in there since pretty much the very early part of 2016. So Arizona Sky Village is located in southeastern Arizona. The star marks the spot. And as I'll show you later, there was a cloud right here. I mean, just right there. That's it. The entire state was clear except for one little cloud right there. So Arizona Sky Village is really part of the Portal, Arizona community. So let me give you a quick tour of downtown Portal, Arizona. Here's the post office. So you can see here, Portal, Arizona, zip code 85632. From what Mike Patton tells me, the lady that runs the post office is probably pushing 90 now. I hope she's doing okay. And nearby the post office, a short walk away, no subway required, is the Portal Store Cafe and Lounge. And ladies and gentlemen, that concludes our tour of Portal, Arizona. That's it. So it is pretty dark out there. They're right next to the Coronado State Forest, or Coronado area. I forget exactly what the park is called nearby, but this entire region is national parkland. So it should stay undeveloped for many, many, many years. So Arizona Sky Village is pretty well protected. So on the Bortle scale measuring light pollution, you can see I have Arizona Sky Village marked here with the X. You know, X does mark the spot there. And you can see from kind of the darker gray, it's kind of an upper level 2, kind of a short-changed Bortle 1 site. There are some, minor light domes on the horizon here and there. So that's why I guess we didn't get the Bortle 1 rating, but we are pretty close. It's about as dark as you can get. It's definitely darker than pretty much anywhere in Michigan, including the Upper Peninsula. And so here is Peishi Observatory up close. It is a 20 by 20 roll-off roof observatory, and you can just see the remote telescope sticking out there. You can see both the 20-inch plane wave and the 4-inch Takahashi. So it's a pretty full observatory. There are currently 4 telescopes in there, 3 of which belong to Mike Patton. And of course, this baby is all ours. And you can see over here is the weather station. And this little funky thing right here is our all sky camera. So it's getting pretty old by today's standards. We're kind of looking at upgrading this to something a bit more sophisticated, but this is our SBIG All Sky 340C, which means it's a color camera, and it shows us the entire sky. So let's go ahead and switch views here. We'll go back to my web browser. And you can currently see we have ACP here. This is ACP, what we use to control the telescope. Whoever last used the telescope tried to image Jupiter. I keep telling them the remote telescope is not suitable for the planets, but you can clearly see Jupiter and 4 of the Galilean moons. But Jupiter, of course, is greatly overexposed. It pretty much always looks that way, no matter how short of an exposure or no matter what filter you use. I mean, it's just not meant for that type of imaging. So let's see, let me back up my tabs here. There we go. So it's looking a lot better now. So this is our current all sky camera view. We have it set to take an image every, oh gosh, what was it? It says here somewhere, every 4 minutes. So occasionally you'll see the screen load. It's set to reload every 4 minutes, but unfortunately the camera and the reload of the browser are never quite in sync. So the camera is usually a few minutes off at most. And you can see there's lots of red pixels. The camera is still pretty warm. It'll get better. The image quality will improve as it cools off, and all of those will go away. And this little red glow is glare on the roof as it's rolled off. We need to really work with Mike Patton about how much light he has in the interior of the observatory. Even though it's red, it's just too much. And this is our new neighbor just to the south of Mike here. And sometimes he has his lights on. They're really annoying. And if we're ever out there in person, we need to have a little chat with him. And this little funky thing here, which is all to one side for some reason, is the bird perch, because previous to our use of the bird perch here, our installation of the bird perch, birds would always want to land on the dome, to have the highest spot to survey prey or look for predators or something. And so they would leave, bird droppings. And our problem hasn't completely gone away. The camera looks pretty decent right now, but this has really helped keep birds off the dome and doing their business on the dome. And let me show you our neighbor's all sky camera. So this is what we really want to get to. His image is much clearer than ours. He uses a nice ZWO camera. I forget the lens that he uses, but it's really nice. It's a really, really nice lens he has on the camera. It's a more modern CMOS camera and gives a much cleaner image. The only problem is these 2 big domes in the way. The local residents call this observatory Dolly Parton. I'll let you figure out exactly why. So the cool thing about this is it's a lot larger image scale. It takes a second to load there, and really shows you the sky there at Arizona Sky Village. Got a streak there. That's interesting. Possibly a satellite. So we can see the summer Milky Way. The central bulge is just now starting to set behind the mountains of Cave Creek Canyon. And you can see Sagittarius here, the teapot. It's starting to dump out its tea here. Of course, the tea goes up into the sky, which is the Milky Way. So we can still see at least one southern summer constellation. But high above, we still have the summer triangle. We still have Vega, Deneb, and Altair. And we'll be looking at a few targets in or near the summer triangle here tonight, because we'll take advantage of some of these summer objects while we still can. And of course, Vega is part of the constellation Lyra, which is a little isosceles triangle and a parallelogram. These two stars here and these two stars there. So it's a rather small constellation. And then from Vega, which is part of Lyra, but again, which is a harp. I didn't mention that. We go over from Vega to Deneb here, and Deneb is the tail of Cygnus the Swan, and of course, one corner of the summer triangle, but it's also kind of the top part of another asterism called the Northern Cross, which goes from Deneb to Satyr to Albireo here. There are a couple more stars in the neck, but they're kind of lost in the Milky Way there. So we basically have like the swan, or the bottom of the cross, the swan's neck. Back here is the tail. The cross is only these three bright stars here, but for the wings of Cygnus, they go out to these three stars here and this star here. So you can either see the cross or the swan, which is flying kind of toward the southwestern sky there. And then last but not least is Altair, which is the head of Aquila the eagle. And Altair is at the base of a triangle here. There's a triangle for the eagle's body. The tail's kind of the tail kind of goes out to, I think, these two stars there. And then there's kind of like a straight wing here and a crooked wing there. And so there's our constellations and stars of the summer triangle. Now, of course, we're way into fall time now. Otherwise, we wouldn't be doing online viewing sessions. And the dominant asterism of the fall is the Great Square in Pegasus here. So these three stars actually belong to Pegasus. This is the back of the horse because he's flying upside down. This is his head here with the star Enif. And we'll look at a target right about here later on. Some of you might know what that is already, but we'll save it for later. So this is the top of the head, back of the horse, the flying horse. This is his front. And he has like a leg here and a leg here that's bent. And this star is Alpheratz, which is technically the head of Andromeda. So Andromeda is like these two arcs of stars. I think you can just see the end of the arc there. That's probably it right there. But there's kind of a bottom arc with three stars here. I think it's this one. And then there's three more stars here. This one, and that one. And you can see a little glow right there. And that, of course, is the Andromeda Galaxy, which we will be looking at here a little bit later tonight. This is one of the targets we do every season because I try to cycle objects around so we don't look at the same thing every year. But Andromeda and like the Orion Nebula, those are exceptions. We do those every season because, you know, the public demands it. And down further south, you can see what looks like a smile of a Cheshire cat. This is the constellation Capricornus, which is kind of a half goat. Oop, there it goes, just reloaded. It's a half goat, half fish. And then kind of starting from here, we go upwards, and there's the water jar down to here. And around this area is Aquarius. And then we probably have to switch back to our camera. Oh, nope, not that one. That's the telescope there, at least it was. There it is again. Well, let's look at the satellite view here. So this is the old view. This is probably outdated now, but here's pretty much the entire state of Arizona. I guess there are some clouds up there, but there's a little puffy cloud right there. And right below that cloud previously is Arizona Sky Village, but it has moved out now, but I'm not going to bother to reload the camera here. Tab, there we go. I'm using the wrong command. So just below Andromeda, boy, oh, here's the Great Square. Boy, it's hard to find. We see Jupiter here, and around this region, I'm having trouble making them out. We have Aries over here and Triangulum. So that concludes our tour of the night sky. So we'll kind of escape there for just a second. Actually, I don't think I wanted to do that, but I did it anyway. You know, remember that we haven't done one of these since February, so I'm out of practice. Let me go back to the screen here. And so the first telescope that we're going to use, as always, I I very rarely start with the big one first, but sometimes I do, is we're going to start with our scope that rides piggyback on the main scope. This is our Takahashi FSQ 106 EDX3. And so basically, I'll let you kind of read the details here as you see fit. It's a 4-inch refractor with multiple elements built in, multiple lenses built in to give you as sharp as image as possible. But we've had issues in that department. It's probably a collimation problem. So most likely after the season, we're going to send it in to get it collimated. And last season, we replaced the stock focuser, which could not handle the weight of our massive camera and filter wheel, with a very high quality Moonlight Nightcrawler 2 focuser. So that was a pretty significant upgrade for us. And yes, on the back of the telescope there is our camera. And today everyone is switching over to CMOS cameras, and we might do that ourselves here in the near future, but we still have our SBIG STX 16803 CCD camera, which are shortly becoming a thing of the past. The more modern CMOS cameras, they tend to have a much cleaner image, much freer of noise than CCD cameras like this has. But I guarantee you, when we do switch to a CMOS camera, unless we can get some really, really generous donations, we'll probably downgrade a bit in terms of electronics, because the electronics on this thing are first rate, because you often hear people with the like ZWO cameras that are very, very common, that they can't get them down to -20 in the summer. And I've used this camera on either telescope, because we have identical cameras on both telescopes. It's been up in the 80s, and I always get this thing to -20°C without a problem. So it is a great camera. So that's our starter telescope and camera. So let's introduce our very first target of the night. I'll switch back to the slide here shortly. Well, actually, I'll just go ahead and keep it up. I'll do the switch here in the background, because I have to tell the telescope, of course, what target I want it to go to. There we go. And I'm kind of picky here. With this target, I want it to go to some very specific coordinates. Let's see. So I'm just gonna type in NGC 6960. I'll just hit get coordinates, but I don't really need to. And then, so we're going to go to the coordinates you see on your screen there: 20 hours, right ascension, 51 minutes. And I don't know how precise I need to be, but I'll type in what I have there: 24.985 seconds, because I've checked this out in advance previously, and it frames much better this way. And I forgot to change the focal length in the ACP settings, so I'm going to have to go do that. Otherwise, it's not going to find anything, at least not very well. Well, I take that back. It'll do pretty well. I'm going to use an H-alpha filter for 10 minutes. But before I do that, oops, I just lost a connection with the remote computer. There we go. It's back already. So those of you that have been attending the sessions for a while know I forget to change the focal length a lot, because ACP only accommodates one telescope at a time, and there's no quick way to switch them other than go into the preferences and do it yourself. Okay. So I'm going to hit acquire image, and off it goes. It'll do everything on its own. So before I do that, let's go back to the web browser here, and let me switch. I don't need that anymore. We can go on this camera here, because we're having trouble with the other camera. I'll come back to why later. And it should slew here any second. So here's the remote telescope live. You can see, oh, it's starting to move now. So there's the 20-inch now, and the mount now slewing. And we have this pesky 7-inch refractor in the way that blocks our view, but our camera gives a better view, but I can't get it to load in Edge anymore. And the Edge browser was the only one that I could get it to consistently play the video. With Firefox, it just freezes. I don't know about Chrome, but there's the scope, and I want to turn off the infrared camera because that thing is horrendously bright. And you can see all the power lights going on there. So quite a few lights in there that we need to probably take care of in the future there. So let me give you a little intro of this while we're waiting. So we'll start with NGC 6992, 6995, 6960, which is collectively known as the Cygnus Loop. Many people know this as either the Eastern or Western Veil Nebula, but collectively, many call it the Cygnus Loop, including me. So yes, the Cygnus Loop is best known as the Veil Nebula, and it's also lesser known as the Cirrus Nebula or the Filamentary Nebula. You'll see where that name comes from when we see the first image here. And of course, several components have different names. So NGC 6992/6995 is this part here, and this very nice sketch. I think 6992 is the bulk of it here, and this is known as the Eastern Veil Nebula. And then down here, we have NGC 6960, which is the Western Veil Nebula. And so these are located just kind of below the wing. I'm not sure which wing. Do we see the top of the swan or the bottom of the swan? It's either, of course, the left or right wing of the swan. And so this is the approximate position of the Veil Nebula. It's actually pretty much in this entire area, but the bullseye here shows you right where the center of the target is. So 6992, the Eastern Veil Nebula, is located 3 degrees southeast of Epsilon, right there, Cygni, or 4 degrees west of Zeta Cygni. These stars make it fairly easy to star hop to for the beginner. And 6960, of course, is known as the Western Veil Nebula, or as I prefer it, the Witch's Broom. We just had Halloween here a couple of weeks ago, so that name's much more appropriate for roughly this time of year. And that is also located about 3 degrees south of Epsilon Cygni, and you can see it superimposed with 52 Cygni. That is kind of the bright star you see when you actually observe this thing through a telescope. And so multiple parts of this nebula were discovered by William Herschel on September 5th and September 7th, 1784. And these include the main parts like NGC 6960, 6992, and 6979. I hope you guys are taking notes for later. So, of course, the Cygnus Loop, or the Eastern Western Veil Nebula, is a supernova remnant, the remains of a star that exploded. So as we're waiting for the image here, because it's still going in the background there, we'll give you a bit of background on this object. We don't do this for every object, but this is a special case here. Is, of course, in the cores of all stars, at one time or another anyway, they fuse hydrogen into helium. So that's basically, protons into helium nuclei. So eventually all the protons or hydrogen nuclei are used up to make helium nuclei. And when that happens, the core of the star becomes almost pure helium. And at first, it can't generate further fusion because it's not hot enough. So what happens is the core begins to contract under the influence of gravity, and it heats up. It gets hotter and hotter. Now that extra heat ignites a hydrogen shell just above the inert helium core. And so eventually the core will get hot enough at a temperature of 100 million Kelvin to ignite helium fusion. You have what's called a helium flash, which releases a lot of energy that we never get to see. And then helium fusion begins. And then you have helium fusion in the core and hydrogen fusion in the shell. And then eventually the helium runs out and helium makes carbon and fusion. And then as the core begins to contract again, the outer layer now begins to fuse helium. And so, long story short, as one element is used up or exhausted to make the next element in the chain, you get a new shell above that. So you get multiple fusion shells as one element after the other, one type of gas after the other is exhausted. And during this whole time, the star is expanding and contracting and expanding and contracting. And then eventually you get to the iron fusion phase. Now, iron fusion is bad because it doesn't last very long. So here we have in a 25 solar mass star, helium fusion in the hydrogen lasts about 7 million years. And then helium fusion only lasts 500,000 years. Why so much less? Is because there are far fewer nuclei of helium to fuse than there were for hydrogen, because helium has more protons than hydrogen does. So each fuel, there's decreases. There's less of it as it becomes more complex here. And then, yep, as you get down to carbon, 600 years, oxygen, half a year, silicon fusion lasts a day. And then when you get to iron fusion, the core collapses like that. I'm trying to snap my fingers there next to the microphone. It collapses in about 1/10 of a second. And then when the iron core collapses, the outer layers implode and rebound into a supernova explosion like this. Kaboom. Of course, there's no sound in space, but I'll add the sound effects there. And you can see this expanding cloud, and it looks kind of filamentary there after a while. And that's what the Cygnus loop is. It's this expanding supernova explosion. And of course, during the explosion of massive stars, that's where elements like the oxygen you're breathing comes from, or the sodium you have in your body, or even the bits of calcium in your bones. It's all the elements in the periodic table are made mainly through some form of dying star or stellar remnant. All right, so this slide means we switch back and let's see how ACP is doing. All righty. And pretty soon here, I'll let you folks chat here. Oh, that's the wrong screen. Oh, there we go again. Whoa, see, he has his red light again. Look at that guy. We really need to talk to him. Look how obnoxious that is. Somebody email him and tell him we got an online viewing session going on there. All right, so we're still roughly a little past halfway through our exposure. You can see we have successfully acquired a guide star. And as soon as it's done with the image, I'll hear some dings in the background. But until then, let's go ahead and stop sharing the screen here. I will allow you to unmute yourself. And while we're waiting, if anyone has any questions or comments or just wants to say hi, you're certainly welcome to do so.
Hello, Richard from Houston. Krishna, how are you doing?
Oh, fantastic. It's great to have you from Houston there.
Great to be here, Richard. You're always wonderful with information.
You are very welcome. It's fun.
Are you planning to come to the great eclipse of April 8th?
Yes, we're going to Uvalde County.
Okay, I'll be in Waco, Texas.
All right. So I see the Loveland, Colorado, Carlsbad Canyon. Of course, we know Elviro, he's a member from California. Yeah, we got members all over the country. Buckeye, Arizona. Hopefully it's clear over you. It's getting clear where we are now, finally. And we got one from England. So welcome, George.
That's me.
Oh, great. Welcome. So yeah, we got people from all over the world. Welcome. So any questions about the Veil Nebula, astronomy in general, the telescope, the club itself? Because we certainly have time to kill here.
we look forward to the talk by Espernak and this guy, Alan Dyer.
Yes, I will definitely be plugging the Dyer talk here at the end. Let's see how we're doing there. We got about 100 seconds left, about maybe 1 minute. I'm sure the timer isn't precise there.
So, Richard, question for you.
Sure.
I'm on the elements. The discussion kind of ended with iron, right?
Right.
Okay, so with a supernova, this thing went supernova. Does that make any other elements, or is something else have to happen?
Yes, during the supernova itself, many other elements are made, quite a few. But in the core of the star, it ends at hydrogen fusion because, or not hydrogen, iron fusion, because iron fusion absorbs energy. It doesn't give off energy. So I kind of skipped that part. So of course, you want the core of the star to emit energy to help balance gravity, because the energy generates pressure. The pressure opposes gravity. And once the energy source is gone, the pressure's gone. And so gravity begins to win again. Because when the star was forming, gravity was its friend, because gravity helps it get hotter, reaches fusion. But eventually, there's only so much gas in the tank. There's only so much hydrogen. So eventually gravity begins to win again. And that exact timetable depends on the mass of the star. For the sun, it'll last 10 billion years before it becomes a planetary nebula. But of course, really massive stars like that, they last about 7 million years and boop, they're done.
Okay, thanks.
Yep. All right, we got to be getting close there. So we want to make sure we're on the screen. I just heard the ding in the background there. So everyone go ahead and unmute yourself. This is the part where we like to hear the reactions from the crowd. You can see the thumbnail, which looks pretty good. But it takes a second for the larger image to be generated. I'm waiting. Sometimes it takes a second. And we'll get an image or a pop-up window to say the image is finished. But it's taking its sweet time today. Uh-oh. Oh, there it goes. Okay. All right, it's ready. Are you folks ready?
Ready.
Yep. Ready.
Here we go. I wish I had a drum roll sound effect.
That'd be fun.
There it is.
That is really cool.
And that is, quote, live.
That is really cool.
Wow, that's something.
And if you've been attending for a while, you can see Bob Denny, who created ACP, upgraded the size of the preview image here, because it used to really fit on the screen. Now we have to kind of scroll up and down to see the whole thing, but we pretty much have the whole Cygnus loop in there.
What's the artifact, bottom left?
That's pixels that didn't pick up any photons, so kind of missing pixels. We can remove that in processing.
Mm-hmm.
So that's kind of
processes, do we?
I will. I do some processing. I do some light processing before I make it available for download.
Cool.
And then you can tinker with it from there if you like.
Yeah.
Of course, it's only one, not like 100. Usually we'd like to take 100 of these things or so and stack them, but we don't have time for 100.
So what did you say? It was 10-minute exposures?
This is a 10-minute exposure with a hydrogen alpha filter.
Right.
And all that information will be in the file name. And when you download the images, there will be a key to decipher the file name, because you might not know what everything means. Sometimes after a while, I forget. Okay, so of course, this is a type 2 supernova that occurred about 20,000 years ago. You might see different numbers out there, but that number comes from a more accurate distance measurement from the Gaia satellite that gave us a more accurate estimate for its distance, which I forgot already. It was on the first slide. And so the progenitor star, the original star, had a mass of roughly 12 to 15 times the mass of the sun, or 12 to 15 solar masses, as we say. And usually type 2 supernova, or as they're also known as core collapse supernova, because the core of the star collapsed, it'll either leave behind a neutron star or a black hole. Now, we're pretty certain a star in this mass range, from 12 to 15 solar masses, would leave behind a neutron star, much like the famous one in the Crab Nebula. But to date, and we've been looking for a long time, no neutron star from this supernova has ever been discovered. Now, from the image here, it looks pretty symmetrical. It looks pretty spherical to me, but maybe that's just an illusion from our line of sight, because sometimes supernova explosions can occur asymmetrically and shoot the neutron star out like a cannon, or a cannonball from a cannon. So maybe the neutron star was shot out at high velocity through space, but from the view here, it looks pretty symmetrical. So the entire thing is about 120 light years across, or, in terms of angular diameter, it's 3 degrees. It's 6 times the diameter and 36 times the area of the full moon. But given its distance, its true diameter from one side to the other is about 120 light years. So it's really been expanding over the past 20,000 years. And so the debris is expanding at about 373,000 miles per hour. And since we do have someone from England here, that works out to 600,000 kilometers per hour. And it heats the surrounding gas. and it heats the surrounding gas to millions of degrees. And in 1904, this section here was discovered, known as Pickering's Triangle. And it was found photographically by Wilhelmina Fleming at Harvard Observatory, but named after Charles Pickering, who was the observatory's director. So they took that away from Wilhelmina Fleming there. And the analysis of its emissions indicates that it does contain oxygen, hydrogen, of course, and sulfur. Of course, the oxygen and sulfur would have been produced during the supernova explosion. So there we have it.
You can see that in the real color.
Of course, this side is the Witch's Broom. And over here is the Eastern Veil Nebula. So Eastern Veil, Western Veil, if you like to stick to the basic stuff, the better known names. And again, Pickering's Triangle. And you can see there's fainter nebulosity that really comes out there. And yes, it is not in color, because we do use the remote telescope for high-end imaging, and monochrome cameras are much sharper, because, for a color camera, you have to have like a red row and a blue row and a green row. And so that takes away from the resolution a little bit. So monochrome cameras are much sharper. But we do have red, green, blue filters. But of course, for online viewing session, we don't have time to create color views. It would just take too long.
So in other words, it took you 10 minutes because, in other words, we wouldn't be able to see anything if we just didn't take as long as we took to process that light, right?
Yeah, I know we've imaged it with the clear luminance filter before, but one advantage of hydrogen alpha is it really dims the stars down, because we're looking right into the disk of the Milky Way. And if we used a regular clear filter and didn't use any filter at all, you could still see the nebula, but man, the stars would be so big and bright, they would really get in the way of the image. So it looks much, much better in hydrogen alpha.
It does. That's true.
And of course, when you are able to download these images no later than Monday or so, you'll be able to you'll have the high resolution versions and be able to zoom in and see detail much more clearly. This is a reduced thumbnail here. And again, that would take time to download the image and do a quick processing job. So we tend not to do that here. But this gives a pretty good view here. All right, are we ready to move on? Any more questions about the Cygnus loop?
No, it's good.
All right. So let's go back to the PowerPoint here, and I'll introduce our next target. And so our next target is none other than M31 itself, the Andromeda Galaxy. And I should have stayed on ACP while I was there, because I could have entered the target. So again, you can tell I'm rusty. I haven't done this since February. And this time, gosh, let's see. 5 minutes tends to blow out the core. Let's go ahead and do 3. So we'll do 180 seconds. This time we'll use the clear luminance filter, and off we go. Okay, I should have just kept the screen up, but again, I'm terribly rusty. I'll get warmed up here by February or so, and then I'll get all cooled down again. So here we go, M31, the Andromeda Galaxy. Very famous. And again, you can see this view here is a sketch. I always try to include a sketch on the first slide here, because, you know, sketches really help capture what the object looks like visually. And so if you've ever looked at the Andromeda Galaxy through a telescope, you might find this view quite familiar. So you can see the coordinates of the Andromeda Galaxy. Again, its diameter is huge. Its longest extent is actually even a bit longer than the Veil Nebula, or, you know, the Cygnus loop, but it's very flat because it's a flat spiral galaxy. And at 2.5 million light years, it is the nearest big galaxy to the Milky Way. There are several galaxies that are closer to the Milky Way, including like the Magellanic Clouds, famously, but the Andromeda Galaxy is the nearest big galaxy to us. Sometimes you say you might hear that's the nearest spiral, but many consider the Large Magellanic Cloud. In fact, it's classified as a spiral galaxy. So technically, the Large Magellanic Cloud is the nearest spiral to the Milky Way. But in terms of big galaxies, this one's definitely the closest. It is big. But we'll come back to the exact dimensions here later. So as I pointed out on the all-sky camera, here is the general view, or its general location in the constellation Andromeda. Again, you have those 2 arcs of stars that meet at Alpheratz here. And it's an easy object to see with the unaided eye. It's often considered the most distant object you can see with your eyes alone. And it's mostly, it's not a, you know, there are some galaxies that are a bit further away, at least 1 or 2 that you can see with eyes alone. We'll see one later, but, you know, this is probably one of the it's the nearest big galaxy that's at least easy to see. And so it's located just 1 degree west of Nu Andromedae, which is right here. And it was first noted as a small cloud in the Book of Fixed Stars by the Persian astronomer Abd al-Rahman al-Sufi in the year 964 AD. And the German astronomer Simon Marius was the first to describe M31 after observing it through a telescope in the year 1612. And of course, Charles Messier included it in his catalog in 1764. So it's the 31st entry in the Messier catalog, hence the M31. And as I mentioned, it is the nearest big galaxy to the Milky Way. And of course, the Andromeda Galaxy is in the same cluster as the Milky Way. So there are poor galaxy clusters with, you know, maybe a few dozen galaxies, and there are rich galaxy clusters with thousands of galaxies. And as you might have guessed from the map here, the cluster that the Milky Way and the Andromeda Galaxy are a part of is considered a poor galaxy cluster known as the local group. And at present, it contains 55 known galaxies. They're not all pictured here. And it has an irregularly shaped volume, slightly over 1 megaparsec, or 1 million parsecs, or 3.26 million light years in diameter. And of the bright galaxies in the local group, 14 are dwarf ellipticals, 3 are spirals, 4 if you include the Large Magellanic Cloud, which we should, and 4 are definitely irregular. And you can see the icons here telling you kind of which is which. But again, we do kind of consider the Large Magellanic Cloud here a barred spiral galaxy like the Milky Way. And of course, quite famously, in about 4 billion years, the Milky Way, seen here in greatly sped up time, is due to collide with the Andromeda Galaxy. And we see what's going to happen here. So we see our current configuration roughly today, except for maybe 1 billion, 2 billion years in the future. And we see another galaxy here, M33. You often hear this is going to get absorbed by the Andromeda Galaxy first, but in all the animations that I've ever seen, it never does. So I think M33 might survive. And now they pass through each other. Their gravitational fields will severely distort the other. You'll get huge bursts of star formation. And then eventually the two nuclei will merge along with their supermassive black holes. And the Andromeda Galaxy's black hole far outweighs ours. And the end result is a supergiant elliptical galaxy that'll contain trillions of stars, because the Andromeda Galaxy has a lot more stars than we do. So there we go. And again, M33, it survived, even though you often hear the Andromeda Galaxy will eat it for a snack before it collides with us. But again, it always tends to survive. All right, I only did a 3-minute exposure, so we should be ready. So let's scroll back up here. No, we're not done yet. Oh yes, I did hear a bunch of dinging in the background. It sounds like it took it a few minutes to acquire a guide star, but as we can see here, it's almost done. In fact, it's done. And don't ask me why it goes 2 seconds past the time. That's an ACP artifact. It doesn't actually do that. And this is a rough image of what the guide star looked like. Looks pretty sloppy, but the tracking looked pretty smooth to me. So we'll see the thumbnail there first. Uh-oh, we don't have clouds again, do we? That looks a little funky. Maybe the thumbnail just looks worse than the actual image. Sometimes that's the case. Well, it's taking its sweet time processing the picture today. And the computer's really running slow today. I knew I should have done a restart earlier in the day. Oh well. It'll get there. Helps create anticipation. Oh, there it is. Holy cow. Boy, is that loud. All right, are we ready? Here we go. Whoa.
Whoa.
That doesn't look good. Did I forget to change? No, I changed the filter. Let's look at the weather. Let's switch to.
I have things to do, but for 30 seconds in the room. 20 minutes.
Huh. The weather looks good. That's strange. I wonder what caused it to look so crummy. Well, let's give it another shot, shall we? I know it changed. Maybe hopefully the filter wheel isn't getting sticky. Let's look through the data here, and yep, there's a luminance filter. Huh. Well, let's give it another shot. Let's see what happens. If not, I'll throw in a previous image that looks really good. Because that's odd. What would cause it to look like that? That was kind of a letdown. All right, well, let's let that work in the background. And again, we can welcome people.
Richard, would that be a fresh image capture or would it be additive to the previous?
No, that would be a totally fresh image.
Thanks.
I see we have a group with John Leeson. Where is the group from? Looks like we have people in an auditorium joining us. So where are you folks from? Can you use sign language and tell me? Hold up a map or something?
Can you hear us now?
Whoa, yes, we can kind of hear you. There's a bit of an echo, so you might want to mute your audio. Or just throw it in the chat. That'll work too. Yeah.
Richard, it is on the chat. They're from Cedar Rapids, Iowa.
Oh, fantastic.
Yeah.
So you guys are doing a club event for our session, huh? That's great.
We're in Iowa.
Yeah. Boy, I see Pete mentioned that could be that bright red light, but boy, I'd find it hard to believe it'd mess it up that much. Yeah, we need to work with this guy. That thing is pointed right at us.
Which direction is it at? Southeast?
This is this is southeast. So we are looking high above that, but we're looking more kind of in the western or northeastern sky. Well, we finally got a guide star, but we'll give it one more shot. That's quite curious. That's a new one, but we're only doing a 3-minute shot. But boy, getting the guide star really affects us. Yeah, we're going to have Mike Patton talk to that neighbor and tell him he needs to point that light down. That's offensive.
You should take a screenshot.
I've done that before, but I don't recall it interfering with images that severely. I'm wondering, it almost looks like an H alpha image, but I definitely selected luminance. I'm almost wondering if the filter wheel is getting sticky.
Can you adjust the stretch on that image?
I can when I download it, but I didn't. I don't know if I'd bother to download this view here. Something could have gone wrong with the processing too, but that's never happened before either. So while we're waiting, I'll tell you about ACP here. So ACP stands for the Astronomer's Control Panel. And this is basically a bit of software that controls other bits of software, because we actually use the SkyX to control the mount because it's a paramount. So we have to use the SkyX because they're made by the same people, so they got a little angle going there. And then we use Maxim DL to control the camera and the auto guider. And so ACP controls those programs. It tells the Sky when to move the mount. It tells Maxim DL when to take a picture. So it's kind of like the Swiss Army program of programs, if that makes sense. And we can do another screen share here. I think I'm still sharing the browser, right? Oh, no, I'm not. I forgot. But let me show you what's going on in the background. So this view here is of the computer in the observatory. It's actually in the warm room. Sometimes it's the cool room when it gets really hot. And of course, over here on the right, we have ACP taking up the bulk of the image or screen. Here is Maxim DL. The sky is collapsed because it's really not needed. And then we have this little program here called Focus Max that I use to focus the Takahashi. And then we have our weather station here. So you can see it's very clear, calm. The wind is just 1.7 miles per hour. If you've ever attended sessions before, quite often the thing that tends to get us is the wind. Quite often when we have to postpone a session, it's not necessarily because it's cloudy, it's because it's really windy. And so if the wind speed does hit 10 miles per hour, the telescope will park itself and shut down and the roof will close. And M1 Oasis here, that's what opens and closes the roof. And ACP runs that as well, or it controls that when it's running. All right, looks like we're just about done there. We're downloading the picture. Of course, the first shot looks terrible there because it's not stretched or anything. And just generated a thumbnail because it still looks pretty rotten. Let's see what filter we're on. It says luminance. So that is quite odd. Well, that would be news to me if the filter wheel is stuck, but as mentioned, it's been cloudy out there for the past 3-4 days, so we really haven't had a chance to use it too much.
Can you cycle through the filter wheel to see if it moves?
Yeah, I might do that. I don't know if I want to take the time to do it now. The good news is the next image we're going to do will also require the hydrogen alpha filter. So we'll find out if that's what it is, because that looks so dark. That tells me this is kind of what you would expect in a hydrogen alpha image that's only 3 minutes long. So maybe the filter wheel is sticking. Well, we'll find out. So I'm going to go ahead and skip the rest of Andromeda here. I try to give you some of the technical information here on the galaxy, but since we couldn't really get a decent image, I'm going to go ahead and move on to the next target. And hopefully when we switch to the big scope, that filter wheel will not be sticking because we'll be using a whole different system, a whole different camera and filter wheel there. Now, oh, you folks need to mute yourself back in Iowa there because we're hearing an echo. All right, so here's our next target, NGC 7822, and I believe I gave it the name the Brain Nebula because to me, that's what it looks like. And yeah, I forgot to do it again. Man, I am off tonight. 7822. So NGC 7822. We're going to do that 10 minutes again because this is a faint sucker. And we'll just go back to H alpha. And if that filter, I'll check the filter wheel after we get done here and I'll see if I can cycle it around. But we would get like an error message too if the filter wheel was not changing, because it would know. All right, so we'll go ahead and hit acquire image there. Of course, it'll have to slew a bit. It'll have to move to its new target. And so, yes, the Brain Nebula is my name. You really won't find that online. It doesn't really seem to have a popular name because this is not one of your brighter targets. So this is one of the great things about online viewing sessions is oftentimes we can go after targets that you really just can't observe very well visually. I mean, to see this thing, you really have to have a big daub, like at least 12 inches, preferably bigger. So this is discovered by John Herschel, the son of William Herschel, on November 16th, 1829, using his 18.3-inch reflector. And so the NGC catalog designation here comes from John Louis Emile Dreyer, who published a revision of the Herschel's catalog in 1888. So the NGC catalog is based on the previous Herschel observations, but he catalog the targets here as we know it today. But John Herschel cataloged it as H2302 and described it as the following. He said, the central part of what I am positive is an enormously large but extremely faint nebula of a round figure, though I cannot trace its limits, because again, this thing is difficult to see visually. And the Swedish astronomer Sven Cederblad listed it as Cederblad 214 in the 215 Bright Nebulae catalog in 1946. And the American astronomer Stuart Sharpless listed it as Sharpless 2-171 in his 1959 catalog of 313 H2 regions or emission nebulae. And we can see its rough position in the sky here. It's roughly centered a third of the way from Cepheus to Cassiopeia here. And again, it is a difficult target to track down. I have heard people see it in 10 by 100 or 15 by 100 binoculars. But again, you have to have very dark skies to do that, which we don't really have, at least in Southwest Michigan. And here is its general location in Cepheus, just outside the top of the roof of the house here. So in the background, I don't know if you can hear that, but you can hear the telescope acquire a guide star. Let's switch to ACP, see how we're doing. So there's our guide star. It just popped up, and now we're guiding. We just started our 10-minute exposure. So while we're waiting, let me cycle through. This is the old. I should probably just go ahead and get rid of this because that's pretty old. I don't want to turn on the camera because the infrared view may screw up the view. And this is a better view of our telescope. But let me do a hard reload on this thing. It's because in Firefox, it tends to freeze all the time. It'll play for like 30 seconds and then, it freezes. So this should be the current configuration of the telescope. And maybe the infrared light on the camera messed up our view, but it's never done it so severely before. We've had this camera on plenty of times, and it's never affected the views of the Andromeda Galaxy. So again, I suspect a sticky filter wheel. And so you can see the flip flat is open. We use this to take flats for the Takahashi. It's also the remote dust cover to keep dust off the front of the lens there. So again, the little scope is the one we are currently using for our third and final target for the Takahashi. Then we'll switch to the big target here. And let's see, this should be a relatively current view here. You can see Jupiter is above his dome. And again, look how his camera is so clean compared to ours. And that guy still has his light on. Yep. We need to talk to him. What I need to do is have Mike Patton give me his email, and I will email him and say, hey, dude, we're using the telescope tonight, or when you see the roof off, turn the light out. He apparently is not a advanced amateur astronomer, because anyone that's been doing this for a long time knows that's a big no-no. Do not do that. That's bad. And it's hard to tell, from the infrared view if that light is affecting the inside of the observatory. You think the walls would block out any light from a source like that. And there we go. So the scene looks pretty smooth. The guiding curve there is pretty flat. Sometimes it does get pretty spiky out there. And so let me switch back. We'll switch back to the other camera. It doesn't have the annoying light in it. And here's Cassiopeia. Let's see. This is the tip of Perseus. I'm having trouble seeing Cepheus. It's got to be over here somewhere. I think, yeah, here it is. So our target is right about there. That's where we're imaging. I don't think it's this little patch right there. That's a little too close to Cassiopeia. It should be somewhere right around there. All righty. Oh, that just really burns me the wrong way. That guy should know better. So we still got a ways to go. So again, plenty of time for comments and questions. If anyone can think of any dirty names to call that neighbor, put them in the chat. We'll send them to them.
You want to nickname him Sunset?
It's like the sunset that never ends.
Or perhaps we're flying in a jet towards the sunset and keeping pace.
Right. So how many folks are attending the session for the first time? So I see some hands there.
This is my first time.
Great, welcome. Anybody want to share how they found out about the session? Did you see it on our Facebook page or the Sky and Telescope listing, or how'd you hear about us?
Richard, it's Chris Shumay down in Texas. I was a member of your 2022 class, and I received an email from you regarding it. I'm glad to be on board. And a quick question for you. Are there opportunities to be associate members of KAS if you don't live immediately in the Michigan area?
Absolutely, yeah. During the pandemic, we picked up a lot of people from out of state. So we have, I don't know the exact total right now, but it's got to be 50, 60 people that don't actually live in Michigan. A handful are former members that moved away. Like we have one guy that lives in New Hampshire now that's retired, that was a member of the club from in the early 70s and moved away, came back in the 90s and moved away. So
on the website, there's some guidance as to what to do there. So,
yep. So you can just use the online membership form. That's probably the quickest, easiest way to join. If you send in the hard copy form, it might be a while before I get it, because next month we have our winter solstice party. And that's not at our regular meeting site anymore because we got tired of putting out tables and chairs for 20 years. So that's where our mail goes. So unless the guy that teaches there, who's a member, brings our mail to the December meeting, I won't get it. But if you send it online, I get it right away.
I think online it is. Thank you very much.
Yep. It costs like a buck or two more, but that's because of those pesky PayPal fees. We hate them. But they got to make money too, you know.
Well, from England, Richard, we got a notification last year of one of your events through our Astronomical Society. So I came onto that. And then as a result of registering on that, you sent out the details for these events.
Yeah, for you, it's pushing like what, 2 o'clock in the morning for you?
Yeah, I'm going to get a rocket in a minute if I don't go to bed. So
well, it is astronomy after all. You're supposed to be up late when you're doing astronomy.
Well, the thing was, when I put it in the calendar, it said 8:30, and of course I realised the time difference. And my wife said, "No, you're not going to watch that." I said, "Yeah, I'm going to watch that." So I went to bed. I woke up at 1:10. So time to come and join you, but I'm going to shoot off in a little while.
Well, we very much appreciate it.
No, it's been great. I love the images. The first one coming through. I'll wait for this image and see what's happening there.
Alrighty,
pretty cool.
Yeah, I definitely apologize for that poor quality Andromeda image. That's the first. We've never had that happen before. But my guess is the filter wheel is sticking. But I'll investigate that further when we wrap up here after 10 or so. But
so which scope are we on now?
We are still on this is our last target with the Takahashi. We do 3 with the Tak, and then we do 3 with the big scope.
Well, you're going to look at the H alpha on this one and hope it's still there.
Yeah. So
yeah, okay.
If this one looks good, then we're having trouble switching to the luminance filter.
Yeah.
But afterward, I'll try a couple different filters.
Hey, say George, what time did you say it was there in England?
I've got 2:41 in the morning.
Oh, okay, 2:41. Yeah. Now, are you guys on? You guys on standard time? Yeah, I guess it was a 5-hour
We're now on GMT with form back.
Okay.
Summertime, daylight saving time.
Yeah, you guys call it summertime, right? You don't call it daylight saving time.
Yeah, we call it both.
Okay.
We speak Anglican.
I just wish
Whatever.
we'd stay on standard time all the time.
Yeah.
Yeah. I have to think, because you've got different standard times, whichever side of the country you are, being so big as you are, it's
Yeah.
many hours or just 5 hours or whatever.
Yeah, we always wait to start the online viewing sessions when daylight time expires, because we'd have to wait, an extra hour to start. Instead of 8:30, we'd have to wait till 9:30 for it to get dark out there.
Why I wanted to join this is because you've got, as it seems, you've got clear sky. We get so much cloud, and you're busy doing other things, and when you get time to do it, you can't see.
Yeah.
Yeah. But we've got an outreach a couple of weeks' time. So
Now, according to my weather app, it's supposed to be clear here in Kalamazoo. Pete, is that true? Do you have your camera up?
Yeah, I'm imaging right now. And
It is,
Okay.
it is clear. It is clear.
So-
I was out
Wow.
observing earlier.
I'm
Yeah.
on
Yeah.
NGC 891 up in Andromeda.
Oh, sweet.
Yep.
It's cloudy and windy. Oh dear. Yeah, it's unusual to have clear skies during the online viewing session.
Well, you know what? The seeing's not bad tonight. I was looking at Saturn, and it was pretty crisp.
Sweet. All
Yeah,
right.
the seems exceptional tonight for us.
Mhm.
Right. I heard the ding. Oh, well, look at that. Uh-oh. Oh, did I forget to get coordinates? Oh, I think I did.
Oops.
Because that looks like a better, like the filter wheel moved, and I just redid Andromeda. I think I hit get coordinates. I don't remember. Well, I'm waiting for it to finish processing.
I was gonna say that looks familiar.
That does.
And it looks better.
Yeah, it looks a lot better, but the computer is just really lagging tonight. Maybe the computer's lagging so much it's just not changing the filter. Oh, there it is. Boy, that ding is loud. Okay, it's done. All right, so here we have the Andromeda Galaxy. There we go.
Wow.
That's better.
So didn't you have the H alpha filter in there at this time?
I thought I did. Yeah. I may have forgotten to something funny is going on with the filters.
Okay.
But wow. the first view was definitely the Cygnus loop. That was definitely an H alpha, because when you take an image of that thing with the luminous filter, the stars are just really bright. So somehow the filter didn't switch at first, and now I forgot to hit the get coordinates, I think. And then the filter wheel seems to have switched. That's strange. Because now it should have been a hydrogen alpha view of the Andromeda Galaxy, because unless the filter wheel doesn't change when you forget to hit get coordinates too, but I don't think so. Yeah. That's really curious. Well, anyway,
your local guy needs to check out the filters are in the right location.
Yeah, currently Mike Patton is not there, but when he gets there, we might have him take apart the filter wheel again and tighten it up, because we did have to tighten it up one year because it got loose. We've never had to do
10-minute exposure. Somebody asked. This
should only be 3 minutes. Somehow this doesn't look like it's 10 minutes. It looks too dim for 10 minutes. Because the core, I have no idea what's going on. This is really strange. I'm definitely going to restart the computer later too. Let's back up. Let me give you some of the details on the target here. So again, this is the largest, most massive galaxy in the local group. It's 130,000 to 120,000 light years across. The bright portion that you can usually see through a telescope, like roughly from here to here, that's the 130,000 part. But when you do longer exposures, the disk does extend further out. And that's why we can say it can be up to 220,000 light years. So that's compared to the Milky Way, which is only 100,000 light years across, but it may be bigger. I often suspect that it is. And the Milky Way has upwards of 400 billion stars. We estimate the Andromeda Galaxy has about 1 trillion of them. Some sources say that the mass is 1.5 trillion solar masses versus 850 billion solar masses for the Milky Way. But some studies suggest the Milky Way has more dark matter, and that may actually, in total, may make the Milky Way more massive than the Andromeda galaxy because of that dark matter difference. Now, our galaxy definitely has a 4 million solar mass black hole deep in the heart of the Andromeda galaxy here. There's a 100 million solar mass black hole. So when the black holes eventually merge, Andromeda's is going to have ours for a hefty snack because it's no match for it. And you can see two satellite galaxies here. The little round one here is, of course, M32, which is located just 24 arc minutes south of M31's nucleus, because we actually see the galaxy kind of upside down from this in the sky. And M32 is about 6,000 light years across and contains 400 million stars. It's one of the densest known galaxies. It may have once been a larger elliptical or maybe a spiral galaxy that lost many of its stars to the Andromeda galaxy. So what we see here is actually the kind of a, the naked core of a stripped galaxy. Pardon my French there, but that's a good way to put it there. And it may contain a supermassive black hole of 2.5 million solar masses, which is pretty big for a galaxy that small. Then down below is another dwarf elliptical, because they're both dwarf ellipticals, which is M110 or NGC 205. This contains about 10 billion stars and an area 16,000 light years across, and there is no evidence for a supermassive black hole in this galaxy, which is a little unusual considering this one's even smaller and has a pretty hefty one. So there you have it, the Andromeda galaxy. Finally, somehow delayed. Don't ask me how it happened. I have no idea. I fear if we try to do the next target again, something strange will happen, but I'm going to give it a shot. Let's see what happens here. I'm going to hit get coordinates, and we'll see if it changes. Yep, it did. But the right ascension's not that much different. But the declination definitely changed. So yeah, I forgot to hit get coordinates again. I need to make like a checklist of things I got to remember to do, because I'm doing like 8 things here at once. So sometimes I forget. So let's go ahead and try it again. I'm up for it. I'm game.
So Richard, you're thinking that the when you did that, you didn't say change coordinates. It also didn't change the filter.
Yeah, I don't get that. It should have changed the filter too. So yeah, we definitely got a couple of mysteries going on here.
Okay. Yeah. It's good picture of the galaxy though.
Yeah, I'm glad we finally got it.
Yeah.
But remember, the first image looked terrible. Then I tried to image it again, and that also looked terrible. So that must have been the third image of the galaxy, and the filter wheel must have finally moved because I didn't hit the get coordinates. So yeah, weird. So sometimes glitches happen.
Yeah.
Okay, well, let's switch back to the browser. I want to flip through the cameras again, or the different tabs I got going on here. So we can't see anything there. And let's see what the current view of the telescope is. I'm going to do a Control Shift R, because sometimes it doesn't reload when you just hit the reload button. It can be very stubborn. There we go. Now it's definitely slewed to the north. So it's definitely on our next target, because again, that's way up in Cepheus or Cepheus. And this bright area here, this is the reflector we have on the side of the telescope, because when the telescope parks itself, there's a sensor that bounces off the reflector there and tells it the scope is parked safe, so the roof can roll back on. And of course, the infrared camera is reflecting off of that, or the infrared light on the camera is reflecting off of that, and it's really, really bright. But that really shouldn't affect our view. And I should mention, if we do finally get it, this view of NGC 7822, this will be the first time we've ever done this. So this is a new target. That's kind of why I'm anxious to do it. I don't think I've ever done it in practice before either. So I hope you guys are up for an adventure here to see what we get. But 10 minutes with H alpha under these dark skies should look pretty good. And let me hit reload here. I don't know if this image reloads. Oh, it definitely did. Now it looks a little dimmer. That's curious. Let's see how our neighbor's doing. Oh, terrible. It's still on.
It's the ISOR on.
Yeah. It looks like the 1950s version of War on the Worlds. I feel like we're about ready to be vaporized.
No,
Well,
a BB gun or if you're not nice, or big piece of Reynolds wrap, if you are nice, would take care of it.
yeah, you got to be careful using a BB gun out there though, because they tend to carry more weapons than that. I know Rick Benham, when he goes for a walk, or pretty much a lot of people, when they go for a walk around there, they tend to be armed, because you never know what kind of animal you're going to bump into. It could be a hostile rattlesnake or a mean javelina. So they tend to walk around armed out there.
Is the Roadrunner still out there?
Not that I've heard, not the same Roadrunner, because for a while there, we had a Roadrunner and an owl living around the observatory, and the mouse population went way down. So they came in really, really handy. Because very rarely, when you look at the PEC cam, our web camera that has a better view of the telescope, you can see mice running back and forth on the roof. Mike Patton tried to install one of those mouse sensors that we have in Owl Observatory here in town, because our mouse repellent device works really well, but Mike said he didn't have any luck with the one in his observatory. I told him to try a couple of them because his is bigger than ours. Yeah, so I do not know what causes the lag in processing. Again, we've had kind of a somewhat slow computer before, but we've never had problems before like this before. So it's always an adventure. Earlier in the day, I was thinking maybe I should restart the computer, and like, nah, it's fine. But now I kind of wish I did it. May I'll make that a new rule for earlier in the day of an online viewing session, is restart the computer. We took another computer out there to run the webcam and the all-sky camera, but they have yet to get it installed. I think it's going to take a trip for me out there to finally get it done, because they got other things to worry about out there, and I guess.
Does the larger size of the final image have something to do with the length of time on that last processing?
It shouldn't. No, we've never, like I said, this is our fourth season of online viewing sessions, and the fifth overall, because the first season we did in 2019, 2020, that was in person at Western. But then just purely by chance, we switched to online viewing during the pandemic, which turned out to be great, but we were going to do that anyway. Because like you see here, we tend to pull in people, not just from around the country, but from around the world. We could do that for a hybrid version, but it's much easier this way.
Yeah, but you mentioned that they changed the final image size. I was just wondering if by changing that, it took longer to process it.
I don't think so, because I forgot to do stuff like that before and never had any issues. So it's strange. And every file is the same size, by the way. It doesn't matter if it's a bias file or a dark frame or a light image. They're all 32 megabytes. So every file size is the same. It doesn't matter what's on it. Uh-oh, did you folks lose me?
Nope, I have you.
Okay, my screen is behaving badly here. I'm gonna. Uh-oh. Maybe.
No, you're there.
Okay.
We see you.
Let me. I had to end the PowerPoint because it wouldn't. I'm trying to use my Windows key here, and it's not letting me switch. I know my keyboard desperately needs to be taken apart and cleaned, but yeah, I can't switch at all. Well, that stinks. Now my computer's acting weird. At least PowerPoint is. Well, I'll just do it that way. Here, I'll collapse it. That works. Let's see how we're doing. We're roughly halfway through now. So again, I apologize for the slight delay tonight, but computer things happen. You know that.
This image that we're looking at, or that we're imaging right now, is that I forgot what we're looking at.
We're looking at NGC 7822, what I call the brain nebula. Because if you see images of it, it looks like a brain.
Okay.
I saw one guy online today call it the Flaming Skull Nebula, but that's a different object. That's a planetary nebula. This is not. This is a region of star formation. This is definitely a nebula. And you can see we're looking a bit lower in the sky here, so you can see the scene's a little more choppy than it was. What were you saying, Joe?
I was going to say that we started the session out with the death of a star, and now we're going to look at the birth of some stars.
Yeah.
Yeah.
I'm gonna check the camera. Oh, there we go. Let's go to. Yep, it's still on. Oh, I hate that guy. I don't know what that guy's name is, but I don't like him.
Richard. That's exactly what I do when I've got a neighbor who's got his. I have a neighbor who sometimes has a light on, and it's usually on a Saturday night. Well, it could be any night, but it's like, why do you have the light? What's like? And I'm like obsessed with seeing if he's still got the light on, and then eventually he has it off, and I'm like, good. I feel so much better.
And you can tell this guy's a beginner because he's under the assumption that because it's red, it can be bright, but which is wrong. You want red light just dim enough to read by. If it's this bright, that wipes out your night vision just as much as a white light. You want it to be, just bright enough to read by. Anything else is too much.
What observatory is he lighting up that there's like a little dome?
Yeah, this is new. That wasn't there at first, but yeah, he has a little dome there, which is lighting up his dome too. So yeah, he's not too bright. He might watch this later, and dude, if you're watching, I mean every word I'm saying. You are dumb. You need to be educated. But
why don't you invite him to join your society?
What's that?
Invite him to join your society. You can teach him then.
Yeah, that's right. Then he'll be under my authority. for you South Park fans out there.
I've got a neighbour who's got a white light positioned in such a way it lights up the whole street and right into one of our spare rooms at the front. If I'm seeing, I'm at the back of the house, and the back shades the whole thing. I don't see it, but
well, hopefully, since he is a astronomy enthusiast, a somewhat amateur astronomer, just not a very good one yet, he'll be more amenable to controlling that light or doing something about it, because it doesn't need to be on, number one, that's long, and it shouldn't be pointed, because it looks like from the source it's pointed right at us, but whatever it is.
Yeah.
So, light should be pointed at the ground, no matter what color they are.
Get them to change the wattage of the bulb inside, whatever it is.
Yeah, it's of course the camera takes a 1 minute exposure, so it looks way worse than it really is, but still that's crazy bright. And it ruins our all sky camera. And it looks like we're looking right into the source too. All right, we're finally finished. I hope this pays off since we're behind schedule here. All right, I heard the ding, which means it's done. Now it's going to process the picture. Oh, that popped up pretty quick. Oh, that looks good. Oh, that looks pretty good.
Yeah, it does.
Because again, I have no idea what to expect. I've never done this before. No one's ever done this before, at least with the Takahashi. With our Takahashi, I should be specific there.
For plate solving, is this using a pinpoint?
Yes.
Richard, I know you said you got a dust cover goes over that. Did you have somebody clean the objective lens at all?
We've never had to clean the one on the Takahashi. They've cleaned the mirror of the big scope at least once. There we go. I'm hearing the gong, which means the larger version is processed. Are we ready? I don't want to delay because we're behind here. Well, that looks pretty good.
Ooh, very nice. Very nice.
Oh, it's upside down. The brain's upside down. This is the brain stem, and this is like the cerebral cortex part here.
Really?
I'll flip it over when I send it to everyone, or when I have it available for download. I'll have it oriented so the brain's up top.
I'd never picked that out for a brain.
Yeah, that's what it looks like to me. Again, that's not the name of it, so perhaps someone can come up with a better name here. But when you flip it over, to me it just screams brain. Maybe I'm a zombie. I don't know. We can call it the Zombie Nebula. Brains. All right, so as listed earlier, given the distance of 2,900 light years and a true diameter of the entire thing of 3 degrees, its true physical diameter is about 150 light years. So Cedar Blot 214 is actually the bright portion here. Collectively, it's cataloged as Sharpless 2-171, but from what I can gather, this area here, kind of, the cerebral cortex, as I call it, this is actually NGC 7822. But this has a different designation. So this is the area that's probably more doable in a telescope. And so I'm trying to, looks like it might be around here somewhere. It could be spread out, but it sounds like it's pretty compact. But centered on this nebula is a young cluster called Berkeley 59, which is a knot of about 40 massive stars. They're only a few million years old, and many are still pre-main sequence stars like T Tauri stars in a protostar state like the sun once was nearly 5 billion years ago. And so this cluster includes the star known as BD plus 66 1673. It's one of the hottest stars discovered within 1 kiloparsecs, 1,000 parsecs or 3,260 light years of the sun. It's an eclipsing binary where the massive component is an O5V star. For comparison, the sun is a G2V. And so, there's O, B, A, F, G, K, M stars. So O-type stars are the hottest. And an O5 is about as hot as you can get for an O-type star. It has a surface temperature of 45,000 Kelvin, which works out to nearly 81,000 degrees Fahrenheit. And it has a luminosity of 100,000 times that of the sun. So it gives off 100,000 times more energy per second than the star does. That's what luminosity means. It's energy per second. But it's also kind of a translation for it's 100,000 times brighter than the sun. And of course, that star is probably one of, if not the primary source that illuminates this entire nebula. So there we go. I think that one worked out pretty well. It was a bit of a wait to get there, but yeah, that's a great target. So we will add this one to the circulation.
Can we see that star that you're talking about?
My guess is it's one of these in the center of.
Okay.
This is the cluster.
Mm-hmm.
But yeah, it's hard to find out exactly which one it is. I'd have to research that further.
Sure. Okay.
But of course, that's a project for when you get your images. You can figure it out. Of course, you'll have to play back the recording to figure out what star I'm talking about. But it's pretty easy to do research and find out what the name of the star is for yourself.
Mm-hmm. All
right. Before I get away from ACP here, before I forget again, now I have to hit this command here to switch telescopes. So this will allow us to switch from the Takahashi to the plane wave. All right, so yes, indeed, we will now switch telescopes to the big one, the main event telescope, the plane wave CDK-20, which is a 20-inch corrected dull Kirkham telescope, which means it has an ellipsoidal primary mirror and a kind of a spherical secondary. Of course, you can't see the secondary because we had that covered up when the picture was taken here. And so what did I do? It does have a 20-inch mirror with a pretty big secondary. And one thing you got to remind me to do before I go to the first target is I got to switch focal lengths and aperture. I got to remember to switch that in ACP. Otherwise, the plate solving that Pete mentioned will not work well. And yes, it is a pretty massive telescope, 140 pounds. 6 of us, I don't think we needed all 6, but we wanted to be safe. But 6 people hoisted this thing up onto the mighty mount here. So as noted, it's all carbon fiber construction, which helps keep the focus because carbon fiber doesn't expand or contract too much with changes in temperature. And so here's the business end of the telescope, the imaging train. And again, we have the same camera on the plane wave that we do the Takahashi. If we ever do a switch off the CMOS cameras, we're not going to make that mistake again, because having 2 of the same camera on the same setup, at least running with the same software, has been a bit of a problem. But you can see the camera is kind of turned horizontal here because we use what's called an on-axis guider. So the auto guider here picks stars from the actual field that we're imaging. With an off-axis guider, we're selecting stars that are actually not in the field of view. And so this tends to have its advantages, but it does tend to have some disadvantages as well. And so, of course, everything rides on top of the mighty Paramount, which has a total instrument capacity, I should say, of 240 pounds. And I'll just kind of highlight that tonight because we do need to get going here. So let me switch back to the browser. It looks like we're good to go. We successfully switched telescopes. So I'm going to go off to my first target. Oh, but before I do, let me go back to ACP here and change the focal lengths, because if I don't do that, that would be bad. So 508 millimeters, that's 20 inches, and 3,400, come on, 3,454 millimeters. All right, plate solving will work now. So my first target is going to be NGC 6888, a summer object that I wanted to do before it's too late. Let's go ahead and keep the 10 minutes because it looks pretty good in H alpha. And I did hit get coordinates right. I'm going to hit them again just in case. And definitely got H alpha there, so we'll see what happens. And off we go. So NGC 6888 is known as the Crescent Nebula. And this target, as you can see, is about 5,000 light years away. It's fairly distant. And it's pretty much right in the neck of the constellation Cygnus the Swan. So this is a summertime object, and that's why I wanted to do this one before we get into December and definitely January when this gets too low to image. And so, of course, it has many designations like the Brain Nebula did. It's also known as Caldwell 27, which is a catalog developed by Sir Patrick Moore. His name was actually Moore Caldwell, but he went by Moore, but he couldn't use M because of the Messier catalog, so he came up with the Caldwell catalog. But it's also known as Sharpless 105. It's about 2 3/4 southwest of the second magnitude star Satyr, which is like the center of the Northern Cross, or kind of the body of Cygnus the Swan. And it was discovered by William Herschel, September 15th, 1792. And the nebula shape also resembles the Euro sign. Maybe we'll see that later. And it's also referred to as the Euro sign nebula. Oh, shoot, I had specific coordinates to go to this thing. Well, it's too late now. It'll probably be a little off center, but that's okay. I don't want to stop it now. Let's see how we're doing there. Oh, we're still moving. Yeah, do I want to stop it and put in the custom coordinates? Let's see if we're slewing here. Whoops. My goodness, how do I keep doing that? Oh. All right, that looks no. Oh. Come on. Oh, it's not switching. Oh, you no good thing, you. Oh, let's pop it on real quick here. There we go. That looks pretty good. All right, turn that off. That thing's really bad. I wish the camera was sensitive enough to see if we get like a big red glow from that guy's light. I don't think it's that bad. All right. Hope I'm not getting anyone sick switching screens so fast. Okay, we've already got a guide star, so I'm going to go ahead and let it run there. So it might not be perfectly centered the way that I like it, but it'll definitely be in there. That's a good thing about having such a big chip, because it is a big old square chip. All right, how you folks doing? Looks like we've lost some folks, but most of you are hanging in there, and I do appreciate it. The next target will be a pretty short exposure, so I think we'll make up some time there, because it's very bright. And it's a very famous object, and we've never actually done it before during an online session. We did do it during the first season that we did in person, but we've never done it before. Oh. What size floor monitor do I use? You mean my laptop monitor here? My laptop monitor is it's a 15-inch laptop, if that's what you're asking. I'm not quite sure I understand the question.
I think he meant what size monitor do you use? Autocorrect said floor.
At Arlington Cemetery this morning, the president, alongside the First Lady, Vice President Kamala.
Is that you, Kevin? Yeah, that was Kevin. We know what Kevin's listening to. Kevin's listening to the bad news. It's all bad these days.
Well, sorry, I was just saying that he was asking what size monitor do you use, but floor got in there somehow.
Oh, okay. Yeah, so my laptop has a 15-inch screen. All right, so we're guiding along there. Let me Oh, I got to fix the screen here.
Who makes the flip flap on the Takahashi? Is that Optech?
Yes, that's Optech. Yep.
Cool.
Yep, we've been pretty happy with the flip flat.
Yeah, I'd like to get one for my refractor on top of my scope. That'd be nice.
Yeah, heaven forbid you should walk out back and take the cap off your telescope.
Oh, it's cold outside right now. Like 35 degrees.
Oh, it keeps you awake. All right, so let's here we'll switch around here. See, just kind of peek around. This is what I'm constantly doing in the background, which is why I get distracted sometimes. So here's the observatory computer again. The wind is still holding at 1.7 miles per hour. It doesn't really seem to be changing at all.
Nothing.
Yeah, so we got really lucky tonight, except for the funny lag issues or whatever we're having. And boy, yeah, 10 minutes is a long time.
You closed the whole thing during the monsoon season, and my where my parents live, it's the Phoenix area, outside of Phoenix, but they did have a dust storm. I was there late August, and there was a dust storm that kicked up one evening, and it was pretty pretty awesome. It's kind of like watching a snowstorm, except that you can kind of taste it.
Oh boy,
when you go outside.
So remember, we're imaging like right around, I think it's north of the star, so somewhere right around here is where we're pointing at. So it's still pretty high, even though it's a summer object. And let's peek in there. Oh, there. Let's hit reload. Just make sure it's still on. Oh man, this guy. Oh, I hate him. He could be a nice guy, but I don't like him. He is a terrible person.
Starting to sound like Sinclair.
Well, we've been hanging out for a long time. We've exchanged the terrible character traits between one another. So let me just slow down here. So this is what I use to acquire the individual images. And you can see it keeps a little log of all the stuff we have taken a picture of. So I can make all that go away by folding this screen here, this section here. I forget what he calls them. And then unfold it, and voila, it's all clean. And then, of course, if you want to get into the fancy imaging, it's very similar, but of course you can use a whole different variety of filters. You can switch between luminance, red, green, blue, H alpha, O3, S2, or sulfur 2. So you can, have it do a whole set of imaging through a night. It's also possible to use what's called ACP Planner and create a plan to upload and just have it run it to do a series of objects, because you might ask, well, what if you want to do more than one object a night? And that's where you write a plan, and then it does everything for you. And of course you can click shut down and end run, and when all your images have been taken, it'll automatically park the scope, turn the power off, and roll the roof back on. At least it's supposed to. Sometimes it doesn't.
Richard, how does it compare with Nina?
Nina's great. The advantage of ACP is you can see I'm controlling it through a web browser. So our members that live in the area that sign up to use this, you have to pay an additional fee to use this. Is you don't have to install special software on your computer. You just have to have a web browser, which pretty much anyone that has a phone or tablet or computer does. So you can control this with a phone, tablet, or a laptop or desktop.
First look at it from my point of view, it seems to me so much simpler.
Yeah, it's pretty simplistic.
Yeah.
There's a European version I want to take a closer look at. I think it's called Orion. I forget the full name of it, but that has some more modern features that I want to look into. But so far, ACP has been pretty good for the most part. As one new user found out recently, it tends to freeze once in a while. But that could be again our computer. That computer, it just might need to be tuned up or refreshed or something.
Could be that light from across the way.
Yeah. So usually we tend to wrap up right on time, but I think we're going to go a little overtime today because of our unusual technical issue. I have no idea what happened, but I guess with that Andromeda image, the third time was the charm. So somehow my guess is the filter wheel got stuck. And then when I imaged it by accident a third time, it moved, and then we actually got our picture that time. So that worked out great.
Richard, after this image, I'm going to leave. And
all right, I totally get it. It's late.
I've enjoyed it. I can't wait to see this image.
Yep.
But I'll try and join the next ones as well. I'm going to send your fly around to my Astronomical Society because I think there's a number of people there who would really appreciate seeing some live imaging like this.
Great.
Yeah.
Yep. We usually have totally overcast skies this time of year. So this is our way of making do until we get back to clearer skies.
Yeah. Will you the YouTube link, will that be recorded and people can see it afterwards?
Yes, it won't be available right away. I haven't even had time to process our last meeting yet because we have so much going on right now.
Send a link to that, and I can send that out to them. They can see what the live.
If you send me an email to remind me to send it to you, I'd be happy to do so.
Yeah,
but just basically, have people subscribe to our YouTube channel. It'll be on there.
Yeah. Okay.
And of course, if you're on the online viewing session email list, I'll mention that again later. But if you're not a member, you can sign up to the online viewing session email list, and you get links to download the images later. Of course, the link isn't very good right now, and I also give people the YouTube link to watch the video.
Yeah, I think your last remote flyer had that on it. Yeah, that's cool. Lovely.
All right, we're almost done there. There we go. Okay, it's done. So what happens is, the image downloads from the camera. Maxim processes a thumbnail, and then it processes a preview image. And you can see it's offset like I feared. That's why I had custom coordinates for this, because I remember from before it doesn't put it right in the center, but we can see the whole thing in there. But I was in kind of a rush there. I didn't notice I had special coordinates to type in here, so it's right in the center. And again, it's a little slow on the processing. Usually it's fairly quick, like 10 seconds or so, but tonight it's taking longer. I can try to click on it, but it's definitely not going to be there. In fact, it's processing, so it's not even going to load the previous picture. There we go. Oh, that's going to damage my hearing. That gong is so loud. I don't know if you can hear it as loud as I can. All right, here we go. There it is. That's not too bad. Looks like the clarity maybe has suffered a bit, but you can really see its structure. It has a really cool structure. That's what I like about this one.
Yeah.
So this area here is what you call the crescent part of the nebula. This is what you can see through most telescopes, probably like 6 inches and up. But of course, it looks much more extensive in an image. So this nebula surrounds the 7.5 magnitude Wolf-Rayet star WR136 or HD 192-163. So this is basically the outer layers of a very massive blue supergiant star that expelled them. So it's not a emission nebula per se. It's like, I mean, it kind of is. It's very much like an emission nebula, but this is a massive star that's kicked off its outer layers because Wolf-Rayet stars are just very, very powerful stars near the end of their life. And it measures about 25 light years long by 16 light years high. And again, the nebula is formed by the star's fast, powerful stellar wind that collides with the slower wind ejected by the star when it became a red giant approximately 250,000 to 400,000 years ago. But many Wolf-Rayet stars are blue supergiants as well, but this one's red. And WR-136 is 4.7 million years old and is expected to go supernova within a few 100,000 years. This star is 600,000 times brighter than the sun, 21 times more massive, and 5.1 times larger, and has a surface temperature of around 70,000 Kelvin. So it's even hotter than that previous O-type star, but again, this is a really, really massive star near the end of its life. Kind of looks like a football, or if you watch Family Guy, it looks like Stewie's head.
Yeah.
All right, so there we go. All right, next target. Everyone should know the next target. M space, you got to put the space in there. It's very important. 15. We've never done this during the online viewing session. I was shocked to find that out. And we're going to make this one short, 2 minutes, because even if we do it longer, it gets blown out because it's pretty bright. All righty. Whoops.
Hey, Richard, I was going to ask you, let's say you wanted to do a star. I mean, you're doing like these, clusters or some kind of non-star-like object, I guess I should say.
Deep sky objects, yes.
Yeah, that's right. Deep sky. You know what? It's getting late.
It is.
But anyway, I was going to ask you, well, I mean, I suppose you can always just put the coordinates in there, but does it recognize star names?
Yes, it does. I'm pretty sure. It's very rare for me to try that, but I'm pretty sure it does.
Okay.
Maybe when we're finished up here, I'll just type one in and see what happens. I won't necessarily go to it, but
yeah,
we'll see. Okay. We'll see if it looks up the coordinates. All right. So yes, our next target is M15, which doesn't really have a common regular name, but it's in the constellation Pegasus. It's the most prominent cluster in Pegasus. So why not call it the Pegasus cluster? So as mentioned very early on in the night, it's just a little ways off the star Enif here. It's located 4 degrees northwest of Enif, or Epsilon Pegasi. It was discovered by the French astronomer Jean-Dominique Maraldi on September 7th, 1746. And he described it as a fairly bright nebulous star, which is composed of many stars. So, of course, M15 is a globular cluster, and we find globular clusters in the halo of galaxies, including the Milky Way. So if this yellow region here is the central bulge of our galaxy, and the green area is the flat disk, we can see these red star-looking things as globular clusters that orbit around the galactic center in the halo. And that's where we find M15 and many other globular clusters. There's at least one in the disk of the galaxy known as M71 that does live and stay in the disk of the galaxy. That's very unusual. So as is commonly known, globular clusters are made up of population 2 stars, which are relatively old. They tend to be many billions of years old, even more billions than the sun, and they tend to be metal poor. They're only made up of basically hydrogen and helium and don't have any other heavy elements that we call metals. In astronomy, anything besides hydrogen and helium is referred to as a metal, even oxygen, which is never in a metallic state. All right, so in the background here, as usual, buzzing in my ear, I heard the gong that it's found a guide star. And sure enough, we're off and running. And let me back up here. It's still on, at least according to this image. And let's do a hard reload here. See if we can get a current view of the telescope. There we go. That looks fairly accurate. And you can see the flip flat is definitely closed. So we are absolutely using the 20-inch because, yes, there has been a history where they don't switch properly. We get glitches all the time, but usually not during sessions. This is one of the glitchier ones we've had. But we really had a much worse time last season. So for those of you that weren't around last season, we had to we never scheduled one in November because the roof mechanism was broken. There was like a broken gear. So we couldn't have a session in November at all. And then we had the first session in December last year, and we had issues with the circuit board on the mount. But even if the mount was working, it was totally overcast during both the primary and the cloud date. And then we got clouded out the first January date. And then we pulled off the last two sessions. So last season, we only pulled off two. You can blame mechanical issues, but really the weather would have done us in either way. So it didn't make any difference. So last season was definitely rougher than this one. All right, I heard the chime that says we're done. Where's the browser? I lost the browser. Which one's the browser? Oh, here it is. I didn't recognize it with the scope on there. Oh, there we go. So we got the preview ready. That looks pretty good. So the filter wheel is definitely changing on the 20-inch. And oh, there's the gong. It went a little quicker that time, so that's good. All right, here we go. M15.
Beautiful.
Yeah, you folks aren't oohing and on. Don't do it now. It's too late. It'd sound fake.
Ooh,
I said it's too late. Okay, so M15 contains over 100,000 stars, and it is old. It's approximately 12 billion years old. It has a physical diameter of 175 light years. Its orbit is inclined by 40 degrees to the galactic plane and takes 250 million years to complete an orbit, which is pretty much the same period as the sun around the center of the galaxy, so that's nothing unusual. It has a mass of 450,000 solar masses. And it's one of the densest packed globular clusters known. For those that have observed M15 visually, you know it does have a very compact nucleus. And it's only 1% the sun's iron content. So this is a metal poor cluster. Odds are pretty good. There are no rocky planets orbiting any star in this cluster because it just doesn't have the elements to make planets like Earth. And it may contain a mid-size or intermediate mass black hole of 4,000 solar masses. And I don't think it's visible easily. You'd probably have to really inspect it. But the first planetary nebula discovered within a globular cluster called PEAS 1 is in this cluster that was found in 1928. So there we go, M15. First time we've ever done this during an online viewing session. Any last minute questions, or anybody want to take a quick, anyone need another second to gaze at it? Okay. All right, now I'm all warmed up. I'm not going to switch off. I'm going to go to our last target, one of my favorite targets in the sky, NGC 253. And let's do a whopping 5.
There was a question in the chat about the brighter stars on the right and above. Oh. And then there's another one. How do they determine it has 100,000 stars?
All right. So that's a good question. How do you know how many stars it has? So the kind of the basic means is you can basically like select one corner, maybe count stars and then extrapolate from there. Or you just kind of get a rough idea of how the area changes with distance and then just do a little math in there. So the rest of these stars you see, of course, it's hard to tell where the globular cluster ends and the Milky Way begins, but all the stars outside are Milky Way stars. These are stars in our galaxy. But, maybe these stars, they could be part of the globular cluster. But again, it's hard to tell because it kind of, just gradually fades off into the Milky Way there, and you can't tell one from the other eventually. But with the spectroscope, you can, because a lot of these stars should be rich in metals, while the cluster stars are not. Because these are all pretty much stars in the disk of the galaxy, and they are, I actually got that backwards. These are population 1 stars, while the disk stars like the sun are population, no, I got that right. These are population 2 stars. Again, it's getting late and even I'm forgetting. So I had that right, because you can always remember which are which, because population 2 stars are older than population 1 stars. Like a 2-year-old is older than a 1-year-old. So that's a way to remember the difference between population 1 and population 2 in terms of age. All right, so let's see how we're doing there. We're still slewing because this target is pretty low in the south, but by this time, it should be near its highest. So that's why I partly selected this as our last target. Plus, it's a sweet, sweet target because I love taking pictures of this thing. This is definitely not the first time we've done this. So yes, we're looking at NGC 253, the Sculptor Galaxy, also known as the Silver Coin Galaxy. And you can see it's 11.4 million light years away. With exceptional eyesight and really dark skies, people have reported seeing this thing with the unaided eye. So this could almost be considered the most distant object you can see with your eyes alone, if you have really good eyesight. I mean, you wolf down a lot of carrots and you got great eyesight. You can maybe spot this thing. But for most locations around here, it'd be tough because it's lower in the sky. So many viewers might be familiar with Cetus. That is doable from many mid-latitude locations. But Sculptor is where it does get a little difficult because it's low and there's atmospheric extinction. So, but the great thing about looking at this thing in Arizona is it's 10 degrees higher there than it is here in Kalamazoo. So it's located about 4 3/4 degrees northwest of the 4th magnitude Alpha Sculptoris, right there, and 2 degrees northwest of the South Galactic Pole. So the South Pole of our galaxy points right there. It was discovered by Carolyn Herschel. Hold on there just a second. It was discovered by Carolyn Herschel in 1783 while scanning for comets, which was kind of her occupation, a fellow comet hunter. And Carolyn Herschel was born in Hanover, Germany in 1750. She was the 8th child and 4th daughter of Isaac and Anna Herschel, but she was struck with typhus at the age of 10, which stunted her growth, and she never grew taller than 4'3". And because of the thinking of the day, she never married. For a while, she was like the servant of her household, even her family household. But eventually, she immigrated to England in 1772 to be with her brother William. And for a time, she kept notes while he observed through the telescope. She would take the notes. But eventually, she went on to build her own telescope, do her own observing, and discovered 8 comets between 1786 and 1789, more than anyone at the time. And in 1787, she was granted an annual salary of £50 by King George III. So she became the first paid female professional astronomer. And so she discovered this prominent galaxy, which is a great find because it's a humdinger. All right, let's see how we're doing. Uh-oh, we're having trouble looking for a guide star this time, which isn't too surprising. Maybe it's not a great quality night. You know, from some of the satellite views, there's a lot of stuff that doesn't necessarily show up on the all-sky camera that could be hampering our efforts looking so low. But, oh, I spoke too soon. Looks like we've locked on to something, and now it's guiding. All right, so we're underway. Let's see what the sky looks like. Oh, that's where the scope was. It's not there anymore. We can see, I can try to do a quick reload here. And yeah, so you can see why does it do that? Well, Firefox is a real pain sometimes. It's not even reloading with a hard command. There we go. That looks better. So you can see we're looking pretty low. And it does look like it's even crossed the meridian, just barely. So that's the current configuration of the telescope. I don't remember it being so dark on the left side before, even with the camera. So that's interesting. So we got to be looking right around here somewhere. I could not pick out Sculptor to save my life, not without a chart anyway, but it's got to be, you know, it's pretty low. So it's got to be down here somewhere because we are looking low. And let's do a reload. Yeah, the guy still has the light on. Oh, I hate that guy. I just hate him. I'm going to bash him all night. I hope his ears are ringing. All right, let's go ahead and stop sharing for a bit. I'm falling behind on the chat. Yep. So yeah, everyone's very welcome to join us next time. So, all right. Looks like we're doing good there. Hey, we still got 44 people with us. That's pretty good.
Richard, will you be doing different targets next time?
Oh, yeah. I never do at least the same target with the same telescope. You know, sometimes I might do like the Orion Nebula with the Takahashi one month, and I might do it with the Planewave next month. But I tend to circulate the targets, and for every session, I try to come up with 1 or 2 new targets. You know, tonight it was the Brain Nebula. That was brand new. But as I mentioned, we've never done M15 before during the online viewing session.
Came out good.
So we had 2 new targets tonight. We did do M15 before. When we did them in person at Western Michigan University, we called them remote viewing sessions. But but I wanted to change it to online viewing sessions so people knew they were online. There's nowhere to go except Zoom.
Yeah. Well, I was going to go earlier because it's late my time, but I'm hanging in there. I've got to be hung for a sheep or a lamb.
Well, we got 1 target left. I
got you.
You're doing great.
I'm hanging in there.
Uh-oh. Oh, no. We flatlined. Oh. Let me check the computer there. I still see the star. But when it flatlines like that, that means we've lost the star. So I hope it doesn't chase the guiding or try chasing the star. Otherwise, it'll be very streaky. Well, it looks like it has it back. Well, we'll see what happens. It's too late to stop it now. I'm definitely not going to stop it now. Unless the seeing somehow got remarkably good, but I doubt it.
Looks like an exoclock curve.
But I see the star. It's there. It's definitely there. Here, I'll show you guys. So you can see it move here. You know, sometimes it'll move slightly. You know, there it just ticked up a bit. The other image on ACP, that is not animated. It doesn't get updated, unfortunately. Bob tried to make it do that, Bob Denny, but apparently there was no way to do that.
Yeah, that's a challenging object for guide stars.
Yeah.
Especially off axis.
"15 seconds. And everything works out. This is a sweet looking galaxy. I'm going to build up hype.
Fingers crossed.
I can get a good picture of it from way up here in Michigan. You're going to do good here.
Yep. Well, I'm just afraid we chase the star, and it might be trailed. All right.
Remember everybody to ooh and ah.
That's right. Authentic oohs and ahs this time. Oh, there's the thumbnail. Ooh, even the thumbnail looks awesome. Ooh, 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 ooh. We sound like primates in here. Ooh, ooh, ooh. All right. Oh, that was quick. The computer's speeding up. All right. Are we ready for the last target of the night? Oh my God.
Oh, wow.
Great. Ooh.
Now, wasn't that worth the wait?
Good job.
Absolutely.
Terrific.
Lots of dust.
All right. So online, I could never find people's estimates for the diameter of this galaxy. So I did a little trigonometry, and by my math, I get 91,200 light years across. So it's very comparable in size to the Milky Way. And it's somewhat a barred spiral galaxy, as well as a starburst galaxy for the past 20 to 30 million years. So a galaxy can become a starburst galaxy if it has a close encounter with a neighboring galaxy, what's called galaxy harassment, or perhaps a direct collision with a smaller galaxy that disrupts dust in the galaxy and triggers star formation. And this thing has a supermassive black hole of 5 million solar masses, just a little bit, just a mere, 1 million solar masses more than the sun. And NGC 253, or the Silver Coin Galaxy, is part of the Sculptor group, which is another poor galaxy cluster of roughly 13 loosely grouped galaxies. And it's one of the closest to the local group. So it's one of our neighboring cluster galaxy in a cluster of galaxies. I'll work on that sentence and get it back to you eventually. But there we go. Our final target of the night.
Well done.
Beautiful. I love this thing.
Good job. Great job.
Very nice.
All right, so let's wrap things up here before I give you the link if you don't have it already. So, of course, if you do live in Southwest Michigan and one of these counties in red, you can join the Kalamazoo Astronomical Society and use the remote telescope. In addition to member dues, you just have to pay a $50 yearly fee. And trust me, for a commercial telescope like this, you'd pay at least $50 an hour. But for us, it's $50 a year to use this thing. And so you can join us for the next online viewing session. Kevin will post the registration link in the chat. If you don't want to get it off our website or social media, we'll post it on there or wait for it by email. But if you're on our list, either as a member or on the online viewing session email list, you'll get it. But it'll be in the chat. So the primary date is December 9th. But we go back to our 1 week delay schedule because this is the way we usually do it. We'll try for December 16th if we do have clouds or wind, because usually it is the wind. So again, as mentioned, you can, if you're not a member, don't want to join, that's totally fine. But our feelings will be hurt. You can sign up for the online viewing session email list. Again, if you're a member, you don't need to do this. You'll get the regular activity update from the club. So you get reminders about the sessions, registration, YouTube links to download the images, and of course, notifications of postponement or cancellation. You can sign up using our contact form or email us, or I'll try to check the chat later. But you probably don't want to put your email in the chat. So yeah, I probably wouldn't do that. And of course, our next activity is a great one. It is the second installment of our eclipse series. Well-known Canadian amateur astronomer, author, and imager Alan Dyer will present part 1, how to photograph the eclipse. So if you want to take your own images, either simple or sophisticated, and you need a little guiding help, Alan will do that in this detailed presentation. So again, the registration link will be in the chat, or you can always get it off of our website. So be sure to join us next Friday, November 17th at 8 o'clock Eastern time. And as always, people ask, will that be on YouTube? And the answer is yes, eventually. And please stop asking me that question, because I am so tired of people emailing us and asking, is it going to be available on YouTube? It doesn't matter what it is. We get emails about it all the time, and I'm so tired of it. I hate to say it, but I am. I mean, we get it a lot. Many of you mentioned that you found out about us through our introduction to amateur astronomy lecture series. I'm happy to say it's going to return early next year. Part 1 begins on January 13th. And again, the registration link will be in the chat, or you can just go to the amateur astronomy page under the activities tab and sign up today. And if you attend all 5 installments live on Zoom, you will receive a certificate of completion. And then, and only then, will you be an amateur astronomer. And of course, if you do not yet have your eclipse shades, you can purchase those from the Kalamazoo Astronomical Society's Sky Shop. So funding for this helps fund the remote, or sales from this help fund the remote telescope. They help maintain our scope and owl observatory and many activities, including online viewing sessions. So if you have not yet purchased eclipse shades, why not buy them from us? Each pair comes with a 4x6 inch Ziploc bag and an informative postcard that you can keep the glasses in, the bag, not the postcard. And of course, if you are not a member or not on the online viewing session email list, here is the link to download the images. Of course, don't go there now because I haven't downloaded and processed them yet. But I hope to have them up tomorrow. But if not, they'll be up sometime Monday afternoon. You know, I'm only human, folks. I'm doing the best I can. So if there's nothing else, thanks everyone for attending the November 2023